Hi students, how are you all? I'm back with the numericals relative densities of liquid and solid. Okay, in this session we will mainly solve the numericals based on relative densities of a solid or a liquid. But to understand this numerical, you must watch that video where we discussed about relative density of a solid and relative density of a liquid, and link of both the videos are there in the description box. You must check that. So let's start numericals based on relative density of liquid. See the question displaying on your screen. A body weighs 82.1 gf in air, means the weight of the body in air is given. Let's write that. So that is weight in air. Okay, W means weight in air. That's why I'm mentioned A, means weight of the solid in air is 82.1 gf. Okay, and 75.5 gf in water. So weight in water equal to 75.5 gf. It's 75.5? Yes, 75.5. And 73.8 gf in that liquid. So weight in that liquid, understood? Don't be confused with that. Weight in liquid. Okay, when you have immersed that solid in liquid, then what is the weight of that solid? 73.8 gf. Understood? Now number one, find the relative density of that liquid. We have to find the relative density of the liquid. We know the formula. Already we discussed in our previous video how to find the relative density of a liquid. What was that formula? Let's write that. Relative density of a liquid equal to weight in air minus weight in liquid by weight in air minus weight in water. Understood? This is the simple formula. We know that. In the previous video we already discussed. Now let's put the values. Weight in air, it's 82.1 minus weight in liquid 73.8 and weight in air 82.1 minus weight in water 75.5. Understood? Now if you subtract we'll get 8.3 we are getting, yeah, and this is 6.6. okay, 6.6. understood? Now we have to divide this 8.3 by 6.6. now if you divide this, you will get 1.26. This is the relative density of that liquid. So it's very simple, no? Just by using the formula we can find the relative density of that liquid. Okay, now the question is not finished. What we have find in the next part? How much will it weigh if immersed in a liquid of relative density 0.87? You understood the question? See, first we immersed that object in a liquid and we got the weight 73.8 and we have to find the relative density. So we took out the relative density. Now in the next part, the relative density is given. Okay, in the next part the relative density is given 0.87. Okay, a liquid is given whose relative density is 0.87. Now they are asking me what will be the weight of that object in that liquid whose relative density is 0.87. So the same way we have to, but we have to put the value accordingly. Let's see what we are doing. We'll use the same formula. The same formula will be used and so this portion is not required. Fine. So now this is another liquid. We have to find the weight of that object in that particular liquid, okay, whose relative density is what is given? Relative density is 0.87. So this is the second part of the question. Understood? This is second part of the question, number A, and this much is number A and this is B. Okay, so in number A, the weight of the object in that liquid was given and you had to find relative density of that liquid. And in number B, you have to find the weight of that object in that liquid, but the relative density is given. So just opposite, okay, opposite. Relative density is given, you have to find the weight of the object in that liquid. So we are going to use the same formula. Now, relative density of that liquid 0.87. Weight of the object in air 82.1 minus weight of the object in liquid, we have to find that. Okay, say weight of the object in liquid be x. Okay, let it be x. So now we are doing x by weight of the object in air 82.1 minus weight of the object in water 75.5. Okay, if you subtract this 6.6. Understood? Now cross multiplication. So after cross multiplication, what we are getting, if you multiply this 0.87 into 6.6 is 5.742. Now 1 into this 82.1 minus x. Okay, now 82.1, this one I am getting here, minus 5.742 equal to minus x is going there, x. So x equal to, now if you subtract it, we are getting 76.358. 76.358. Okay, so 76.358 GF is the weight of that object in that liquid. So the answer of number B is weight of the object in that liquid is 76.358 GF. Understood? So the first question and the second question are just opposite to each other. How? In first question, the weight of the object in that liquid was given and you had to find relative density. In the second question, relative density of the relative density of the liquid was given. Okay, relative density of the liquid was given, but you have to find the weight of the object in that liquid. Understood? Now the next question, a solid body whose weight is 2.1 Newton in air. Let's write it. A solid body whose weight in air is 2.1 Newton. 2.10 Newton. Fine. And it is given that its relative density is 8.4. The relative density of the solid, okay, this is the relative density of solid is 8.4. 8.4. Understood? What is the unit of relative density? Yes, relative density does not have any unit. Why? Because it is just a ratio. That's why relative density does not have any unit. That's why no unit is given in the question. Don't be confused. Now, the weight of the solid is given. Weight of the solid in air is 2.1 or 2.10 Newton in air, and relative density is also given. Now, how much will the body weight in water? You have to find the weight of that body if the body is immersed in water. Okay, we know the formula. Already we discussed those formula in that video, relative density of solid. Yeah, if you see that video, you will get all the formula. The link of that video is there in the description box. If you want to check, you can check that. Now, we have to find relative density, what is the weight of the body in water? Weight of the body in water. We have to find that. Okay. So, we know the formula, relative density of a solid equal to weight in air by weight in air minus weight in water. Okay, weight in air minus weight in water. This is the relative density of a solid. Now let us put the values. Relative density of a solid means 8.4. Weight in air is 2.1. Okay, now it is 2.1 minus weight in water, which you have to find. So this is x. We are considering it x. Okay. Now just cross multiply it. So after cross multiplication, we are getting 84 into 2.1, 8.4 into 8.4 into 2.1 minus 8.4 into x equal to 2.1 into 1, 2.1. Now 8.4 I am taking that side. 8.4 into 2.1, then 2.1 is coming this side, minus 2.1 equal to 8.4x. Understood? Now x equal to this 8.14 will come down, 8.4, then 8.4. Okay, now see, from these two we can take common this 2.1. 2.1 can be taken common. You can multiply this, no problem. You can multiply, then you can minus. That's not a problem. But to make it easier, without multiplication I am doing. See, I am taking common 2.1. 2.1. So 8.4 minus, if you take 2.1 from here, what is left? By 8.4 equal to x. Okay, so by 2.1, 4 jar. So 8.4 minus 1, that is 7.4. So 7.4 by 4 equal to x. Now if I divide it, then I will get 1.85 Newton. So 1.85 Newton is the weight of that object when you have immersed in water. What do you have to find? Yes, we have to find what is the weight of that body when it is placed in water. That is 1.85. And don't be confused with this calculation. You can multiply it here. Okay, you can multiply it here. 8.4 into 2.1, you can multiply it here, but I am not multiplying because it's a big calculation and decimal points are also there. That's why I am not multiplying. Just 8.4 into this I am writing. Okay, after that, from here, from this part, that 2.1 I am taking common. 2.1. So 8.4 minus 1 is left. So in this way I am doing without multiplication. You can go with multiplication, no problem. Don't be confused. The sum is not finished yet. Let's see what is there in the next part. In the next part, what is the weight of that body when you have immersed that body in a liquid of relative density 1.2? Understood? It's like the previous sum. What is the weight of that body when you have placed that body, or when you have immersed that body in a liquid whose relative density is 1.2? It is same as the previous sum, the first sum of this video. What is that? So we will use the formula of relative density of a liquid. What is that formula? Relative density of a liquid equal to weight of the object in air minus weight of the object in liquid by weight of the object in air minus weight of the object in water. Okay, this is the simple formula we know. In first sum also we have done that. Now let's see what is given. Relative density of the liquid is given. What is that? Relative density is 1.2. 1.2. Weight of the object in air 2.1 minus weight of the object in liquid. We do not know that. Weight of the object in liquid, let us write it x. No, x we cannot take because x already we have taken. Say the weight of the object in liquid be y. Y we can take. So this is y. By weight of the object in air 2.10 minus weight of the object in water. What is the weight of the object in water? We have already calculated in the first part of this sum. 1.85 Newton. 1.85. Okay. Now 1.2, 2.1 minus y by 2.10 minus 1.85. 0.25. 0.25. Yes. 0.25. Okay. Now if we multiply 0.25 into 12, what we are getting? Let's see. 12 into 25. 1, 2, 3. 1, 2. 0.3. Okay. By multiplying this, we are getting 0.3. 0.3. 0.3 equal to 2.1 minus y. Now minus y is coming this side. 2.1, 0.3 is going there, minus 0.3 is going there. So y equal to what we are getting? 1.8. So 1.8 Newton. This is the weight of that object in that particular liquid whose relative density is 1.2. Yes, understood? I repeat, 1.8 Newton is the weight of that object when you have immersed that object in that liquid whose relative density is 1.2. Understood? See, the next question is displaying on your screen. A solid whose weight is 50 gf in air and 44 gf when completely immersed in water. Actually, let us draw it. Say, this is the vessel and this much water is there. Okay, this is the water level. Now, what is the object weight in air? So, weight in air, it is 50 gf. Yes, it is given 50 gf. 50 gf. Okay. Now, when you have taken that object and immersed in water, this is the object which I have immersed. Okay. Then the weight of the object will reduce. So, what is the reduced weight? Reduced weight is 44 gf. So, weight in water. Yes, weight in water is 44 gf. Okay, so how much weight is reduced? Weight reduced is 50 GF minus 44 GF, that is 6 GF. Okay, this 6 GF is, yes, 6 GF is the upthrust. Okay, this upthrust. Fine. So upthrust is equal to 6 GF. Yes, 6 GF. 6 GF is the upthrust. Now the question is not finished yet. What is the volume of the solid? Okay. Now, when you have immersed the solid in that liquid, then the water level will go up. Water level will go up. So this is the displaced water. Okay, this much is the displaced water, and you have to find the volume of this solid. To find the volume of this solid, we will take the help of this displaced water. Okay, the weight of displaced water, water equal to, what is the amount of upthrust? That is the amount of weight of displaced water. What is the amount of upthrust? 6 GF. So weight of displaced water is 6 GF. Fine. Now, weight of displaced water is 6 GF. That means the volume of displaced water is 6 centimeter cube. Okay. Volume of displaced water equal to 6 centimeter cube. Understood? What is the weight? That is the volume. Only for water. Okay? Why? Because you have to write the reason in bracket. Since density of water equal to 1 gram per centimeter cube. Yes, that is only for water. Okay, the rule which I have written is only and only for water, because the density of water is 1 gram per centimeter cube. 1 gram per centimeter cube. That's why, what is the weight of water? That is only the volume of water. So what is the volume of this much water? The volume of this much water is 6 centimeter cube. 6 centimeter cube. This 6 centimeter cube is the volume of this solid. Okay, so when you have immersed a solid in a liquid, then the liquid level will go up. That is called displaced liquid. The volume of the displaced liquid is equal to the volume of the solid. So volume of the displaced liquid equal to volume of the solid. So what is the volume of the solid? Volume of the solid equal to 6 centimeter cube. 6 centimeter cube. Understood? Now, what is the third part of this question? The relative density of the solid. Relative density of the solid, you know the formula. The second sum we have done today's second sum. Relative density of the solid is relative density of the solid equal to weight in air by weight in air minus weight in water. Okay, weight in air by weight in air minus weight in water. The simple formula we have already discussed. Equal to weight in air, that is 50 GF, 50. Weight in air 50 minus weight in water 44. That is 50 by, this is 6. That is 25 by 3. 25 by 3 means 8.3. Yeah. So relative density of the solid is, which we have to find here. Yes, it's 8.3 or 8.33. Okay, so you understood this sum? So we discussed about the numerical based on relative density of solid and then relative density of liquid, and all this formula we have discussed in our previous video. As I told you, link of all these videos. See here what we have done here, the numericals. To solve this type of numericals, you will have to have the idea of Archimedes principle. Number 2, force of buoyancy, upthrust, displaced water, then all the formula of relative density of liquid and relative density of solid. All these 5 things you have to know to solve all these numericals, and link all this link of all those videos you will get in description box. You must check that. Understood? Thank you.